Welcome to homework.
In this problem, we have an oscillating LC circuit where the inductance is equal to 1.25 henries. The potential energy is 5.70 microjoules. The charge is equal to 175 microcoulombs, and well, that's all the information we have. What the problem is asking us is if this system is equivalent to a mechanical system. Then we need to figure out we need to figure out several quantities of this mechanical system. So in order to do this, we need to find what is the relationship between an LC circuit and an equivalent mechanical system. By the way, mechanical system refers to a spring, a mass and a spring system. So the relationship between the components of an LC circuit and the mechanical system is that in mechanical, the position in the mechanical system is equivalent to the charge in the LC circuit. The spring constant in the mechanical system is equivalent to 1 over the capacitance. The mass in the mechanical system is equivalent to the inductance, and the velocity in the mechanical system is equivalent to the current. So in part A, we need to find what is the mass of the mechanical system. Well, the mass is equivalent to the inductance, and we know that the inductance is 1.25 henries. That means that the mass is going to be equal to 1.25 kilograms. In part B, we need to find what is the spring constant. Now, we know that the spring constant is equivalent to 1 over the capacitance. Now, the capacitance is not given to us in the problem. However, we can figure out the capacitance from the potential energy. We know that the energy is equal to the square of the charge divided by 2 times the capacitance. So that means that the capacitance is equal to the charge square over 2 times the potential energy, or that the capacitance is equal to 175 times 10 to the minus 6 coulombs over 2 times the potential energy, which is 5.70 times 10 to the minus 6 joules. So the capacitance turns out to be equal to 2.69 times 10 to the minus 3 farads. And therefore, the spring constant is going to be equal to 1 over 2.69 times 10 to the negative 3, which is equal to 372. Now, of course, because this is an equivalence, not an equality, the units of this is not really farads, and we know from mechanics that the units of a spring constant is going to be newtons per meter. So we have here the result of part A, and here the result of part B. Finally, in part C, we are asked to find what is the maximum displacement. And because displacement is related to charge, then a maximum displacement is the same thing as maximum charge. We know what is the maximum charge, which is 1.75 times 10 to the minus 4 coulombs. And that means that the maximum displacement is also equal to 1.75 times 10 to the negative 4 meters. And finally, the maximum velocity is then related to the maximum current. Again, the current is not given in this circuit. However, the maximum current is equal to the maximum charge times the angular frequency, which is equal to the maximum charge over the square root of the inductance times the capacitance. And so the maximum current is going to be equal to 175 times 10 to the minus 6 coulombs over the square root of the inductance, which is 1.25 henries, times the capacitance, which is 2.69 times 10 to the minus 3 farads, square root. And so that gives us that the maximum current is equal to 3.02 times 10 to the minus 3 amperes. And therefore, because the maximum velocity is equivalent to the maximum current, we have that the maximum velocity in the spring system is going to be 3.02 times 10 to the negative 3 meters per second. So we have here our final answer for part C, and here our final answer for part D.